In this video, we're going to have a look at an introduction to bivariate data, including explanatory and response variables, and then a look at the displaying and interpreting data for categorical versus categorical associations. So firstly, thinking about bivariate data. What we're doing in bivariate data is investigating the correlation between two different variables. And so in the context of general maths, we're looking at either categorical versus categorical, categorical versus numerical, or most frequently, we're looking at numerical versus numerical. And that's where later on we're looking at scatter plots, we're applying linear models to make predictions. That comes further down the track. Before we get into that, we need to think about the two variables that we're investigating. And so we identify these as an explanatory variable and a response variable. So the explanatory variable is something that is manipulated or varied by the experimenter. And then we're seeing what the response is, how that effect is shown by changing the explanatory variable. And so we're looking at that then as the effect on the response variable. When we're thinking about what we want to do in terms of making predictions, what we're doing is predicting the response from the explanatory variable. So quite often you're asked to identify out of the two variables you're presented some data on, which is the explanatory and which is the response. So some really useful questions that you can ask is by saying, does the explanatory variable, so for instance, does my age explain the change in my shoe size? So that could be two examples there of explanatory being age and shoe size being response variable. Another question or another way of phrasing it is my shoe size impacted by a change in my age? So it's just flipping the sentence there and thinking about it in a different way. So they're a very handy way to think about how we can identify the two different types of variables. So looking at some examples here of how we can identify which is the explanatory and which is the response. For these examples, so we have here years of playing as a professional footballer and the annual salary of that footballer. And so we would think about, well, does the years of playing have an impact on the annual salary? Yes. So our years of playing, if we just want to identify our explanatory, would be our explanatory variable. For the second example, the number of students on campus and the number of lunches sold at the cafe. So again, the number of lunches sold at the cafe could be impacted by the number of students on campus. If it's a day where there's a lot of students out for excursion, there's a camp going on, it's exam period and not many people are on site, the number of lunches sold might be smaller than normal. So therefore, again, our explanatory variable can be identified as the number of students on campus. In the third example, the amount of fertiliser a plant receives and the growth of the plant. So is the growth of a plant impacted by the amount of fertiliser it receives? Therefore, saying the growth is a response to the amount of fertiliser, and again, fertiliser is our explanatory variable. In the fourth example, the mark for your English assessment and looking at the impact of the number of drafts submitted. So potentially here we're expecting the more drafts you do, the better prepared you are, so the better mark you're able to achieve. So is the number of drafts impacting or affecting the mark for your English assessment, which makes the number of drafts submitted our explanatory variable. And finally, weekly milk production in litres and the number of cows on a particular dairy farm. So here we might expect the more cows, the more milk that's produced. So is the number of cows affecting or impacting the weekly milk production? Yes, that makes sense. So again, here we have the number of cows would be our explanatory variable. The reason why we take the time to identify these is so that then we know how to correctly set up our display and to set up our responses to or our investigation of the the correlation between these variables, or helping us identify what type of relationship might exist. Now we're going to shift to talk about investigating associations between two categorical variables. So the two key tools that we use to investigate or display any association are two-way frequency tables, and they could be raw data values or percentage frequency tables, and segmented bar charts. So again, they can be raw data frequencies, or in the case of the example we've got here, percentage. When we're considering our two-way frequency tables, some things to note. Our explanatory variable will always be our headings for our columns. So in this case, the example here, we are comparing or investigating any association between whether someone snores, yes or no, and the frequency of nightmares, whether that would be considered a high frequency or a low frequency. So in this particular survey, people were asked two questions, and the categories there were snores, and that's our explanatory variable, and the response or the impact that we're seeing is the frequency of nightmares. So they're investigating to see, does your snoring have any impact on the frequency of nightmares? And so here in this example, we've got the raw data. If we then want to go and convert our frequency table, so from our two-way frequency table on the left to a percentage frequency, we are always calculating the column totals. So that means to work out what must go in our no low. Okay, our no low would be our number of no and low, 80, divided by our total number of no from the explanatory. So our value here, we would calculate 80 divided by 91 and times 100. Giving our answer correct to the nearest whole number, as we've been asked to, we actually get there 87.91, so we would say 88%. To calculate the high, we can either know that our column will add to 100%, or again, we can calculate our value for high as 11 out of the 91 and times 100. We get 12% there. Again, for the yes column, it's the same process. So this time we're doing the 58 yeses out of the total of 70. And so when we do that, we get 83% to the nearest whole number. And again, to get our yes but high frequency, we're doing 12 out of 70 times 100. So we end up with 17%, and both totals 100%. Here we have another example. So the blood pressure, normal, high, and the age group, 60 to 69, 70 to 79, and 80 plus years of a group of people were recorded. The results are shown in the two-way frequency table below. In this group of people, the percentage of people who have a high blood pressure and are in the 70 to 79 years age group is closest to. Now, something to note here is that our table is given as raw data values, not a percentage frequency table. And so when we are looking at our crossover, our group, 37, that is 37 people, not 37% of people. So first thing that we need to do is convert that 37 to a percentage. Just a little side note, they do put that obvious trick wrong answer there. So be really careful that you're checking what information you've been given and what the question's asking you for. So to convert that, we're going to take the 37, divide it by the total number of our column. So in our 70 to 79 years age group, we've got 60 people total there, times by 100, and we will get 61.67. So that gives us our closest answer is E at 62%. Moving now to segmented bar charts. So this is our graphical display or a visual display of our two-way frequency tables. So here we have the same example as before with snores and nightmares or frequency of nightmares, but this time we've got our percentage frequency already calculated for us. So we're going to construct a bar chart using the percentage two-way frequency table. The thing to note is that each column in our frequency table will form a column in our bar chart. So we don't use the 100% at the bottom, the total, but we just use the 88 and 12 to form our column. Our column labels, so the ones that go along the horizontal axis at the bottom, no and yes, that axis will be called snores. That represents our explanatory variable. So just like in our table, our explanatory variable is our column heading. It is also our column headers or our horizontal axis in our graph. So to draw our graph, we want to make nice straight columns, nice straight lines. We're going up to a total of 100%. So we can start by drawing our full column for each of those categories of no and yes for snores. Our response variable, though, will be represented as the key on the side. So we're going to have a key and we're going to use two different identifiers to show our low and our high nightmare frequency. Before we can go and draw these in, we also need to add our scale on our vertical scale on the left-hand side. So making sure we've got enough room to go up to 100. Oops. And labeling that as our percentage frequency. And now we're ready to go and mark in our two groups within that column. So low goes up to 88% for our no's. And let's choose a colour or a pattern to represent our low. And in our second column, yeses, we've got 83%. So marking as carefully and accurately as you can to represent that category or that group within the category. And then making sure we're clearly showing our high group as well. An example here for segmented bar charts. An animal study was conducted to investigate the relationship between exposure to danger during sleep, given as high, medium or low, and chance of attack, given as above average, average, below average. The results are summarised in the percentage segmented bar chart below. So these are already in a percentage there. The percentage of animals whose exposure to danger during sleep is high and whose chance of attack is below average is closest to. So often we're given the information, there's a lot of information there, and it's just checking that we can accurately identify what component they're talking about and therefore draw out that percentage. And so here we have our exposure to danger high, the rightmost column. If we check our key, our chance of attack being below average is the very dark black. So that means we are talking about this section here on our column. And so reading across to our scale there, we're most closely aligned to 86% of the options that are there. So E is our answer. Another type of example is where you're presented very similar information but asked to convert that to a number of raw data. So in this one, we have a study was conducted to investigate the association between the number of moths caught in a trap and the trap type. The results are summarised in the percentage segmented bar chart below. So again, we're given a percentage segmented bar chart to work with. The additional information here is that there were 300 sugar traps in total. the number of sugar tracts that caught less than 250 moths is closest to. So again, first we need to identify what component are we talking about here and see what percentage that relates to. So here we have our sugar tracts on the left-hand side. Less than 250 is our uncoloured, the white space. And so we are talking about this section here. And so we are looking at 30%. So 30% of the 300 sugar tracts, which means we've got 30 over 100 times 300, which gives us 90 tracts. Again, notice the little trick wrong answer, 30 is written there, but we want the number, okay, be clear, the number of sugar tracts, not the percentage, and so that gives us B, 90 as the answer. The final type of question we tend to get is where we are given the types of variables and asked to identify what's the most appropriate display, or told, as in this case, a display that we want to do and want to know what is the appropriate type of variables to show. So here we've been told that we have a percentage segmented bar chart, and we're saying it's an appropriate display to show the association between the months of the year, given as Jan, Feb, March, so on, and a second variable. So at this point, we need to know that a segmented bar chart is for showing the relationship or the association between two categorical variables. Now, we already have one as a categorical, being the months of the year, and we need to identify out of these options a second categorical set. Okay, so monthly average rainfall in millimetres, no, that is numerical. Monthly mean temperature in degrees Celsius, again, numerical. Annual median wind speed in kilometres per hour, again, numerical data. The monthly average rainfall, but this time given as below average, average and above average, that is categorical. So it's been split into particular groups. We can select a group or a response group rather than measuring a value. And to double check and make sure, E, the annual average temperature in degrees Celsius, no, that is numerical. So that means our answer there, the best option is D, the only other categorical variable given. That brings us to the end of this little section about explanatory and response variables and the intro to how we display two categorical variables.